Hello everyone! Welcome to my channel where I teach you how to be a math genius. If you typically struggle in math or you're looking to improve your understanding of math, this is the channel for you. Also, I will try my best to make these videos user-friendly for teachers, co-teachers, or homeschoolers to utilize as well. If you fall into any of these categories, make sure you hit the subscribe button and the notification bell so that you're notified anytime I upload a new video. Now let's jump in. Today we're going to learn about simplifying. In my previous video, we learned how to distribute terms. Today we're going to dive deeper into what simplification means by using the rules we know so far about adding, subtracting, multiplying, and dividing. By the end of this lesson, you will be able to simplify algebraic expressions by using the order of operations. I encourage you to pause the video and write your solutions to the problems down, and then continue to watch the video to check your answers. Also, comment any questions you have below. Let's begin. First, let's talk about what it means to simplify an expression. So, simplify means to condense an expression to its simplest form. Well, how do we do that? By using the order of operations. The order of operations tells us what order we should perform operations in, such as adding or subtracting. We like to use an acronym to remember the order of operations called PEMDAS. It stands for parentheses, where we use distribution to simplify parentheses, exponent, where we use the power rule, multiply, where we use the product rule to multiply terms, divide, where we use the quotient rule to divide terms, add, where we add like terms, and subtract, where we subtract like terms. There's one more thing that you must know about the order of operations. Some of these orders are interchangeable, such as P and E. It doesn't matter what order you simplify parentheses or exponent in because they end up kind of going hand in hand. M and D are interchangeable as well. The order in which you perform multiplication and division does not matter as long as it's simplified before addition and subtraction and after parentheses and exponents. Lastly, A and S are interchangeable. So the order in which you perform addition and subtraction does not matter either as long as it's simplified before you perform every other operation such as P, E, M, and D. Now let's look at an example. We have negative 9 times 6x minus 10y plus 8y minus 7 times 5y minus 3x. We have to simplify the following expression. According to the order of operations, we have to take care of the parentheses first by distributing terms into the parentheses. So here we have all of our parentheses. That means in each of these spots, there's some type of distribution that needs to go on. In our previous video, we talked about how during distribution, we need to multiply any terms outside of parentheses, such as negative 7 or negative 9 times any terms inside of parentheses. So we're going to start off with this first set of parentheses. And we need to multiply negative 9 times 6x. That's going to give us negative 54x. Then we need to multiply negative 9 times negative 10y, which gives us positive 90y, because two negatives equal a positive. I'm going to go ahead and drop down this 8y because I'm not going to do anything with it yet. But we do need to multiply negative 7 times 5y, which gives us negative 35y, and negative 7 times negative 3x. And remember, two negatives make a positive, so we're going to have a positive 21x. So far, we simplify parentheses. Now it's time for exponents. Well, we don't have any exponents here that we need to simplify, so we can actually skip this rule. Now let's look at multiplication. There's not really any multiplication other than the distribution that we need to do. So we can skip that rule. There's no fraction, so there's no division going on. But there are like terms. So what we're going to do is jump down to A and S, where we add and subtract like terms. So we can check off P, E, M, and D. So let's pick out some like terms. So remember, like terms have the same variable. So negative 54 has an X, and 21 has an X. If we combine negative 54, X plus 21X, we will get negative 33X. Then we also have 90, which has a Y, 8 has a Y, and negative 35 has a Y. So if we go ahead and add 90Y to 8Y, we're going to get 98Y. And then if we go in and subtract 35Y from that, we're going to get 63Y. So we can go ahead and put all of these solutions together for our one answer. And we have negative, let's make that a little smaller, negative 3X plus 63Y. We put a plus sign because 63 is positive, and we write the term with the X first because that is the alphabetical order. Now let's look at another example. We have 10 times 2 times 4x squared minus 5 plus 3x minus 12 minus 5x times 9x plus 13 times 2. Let's simplify this expression. So we know we need to use PEMDAS, which is P, E, M, D, A, S, where P stands for parentheses, E is exponent, M is multiplication, D is division, A is addition, and S is subtraction, right? So there's one thing to note here, though, before we begin. It's important that we know that simplifying the parentheses does not just refer to distributing the terms on the outside, but it also refers to simplifying the inside. So if you have anything such as like terms that can be combined or any multiplication or division that can be simplified first, we're going to go ahead and do that. So in this first set of parentheses, we can simplify that multiplication, and if you look closely to the second set of parentheses, we have some more multiplication here. So I'm going to start off with rewriting 10, because we're not going to change that, but 2 times 4 is equal to 8, and then we put x squared on the end according to the product rule. We did not change that minus 5, so we're going to rewrite that. We didn't change 3x. We didn't change negative 12, so we're going to rewrite that. We didn't distribute the negative 5x yet. We still have 9x. That didn't change. But then 13 times 2 gave us 26. So now that we have the inside of parentheses simplified, we can simplify the outside. So first we need to distribute 10 into 8x squared, which gives us 80x squared. 10 times negative 5 gives us negative 50. We're going to drop down the 3x minus 12 because we're not touching those. Negative 5x gives us negative 45x squared, again according to the product rule. And negative 5x times 26 gives us negative 130x. So now that we have all the parentheses simplified, we check for any exponents that need to be simplified. No, there's nothing we need to use the power rule on. We don't have to use the product rule. We just used it. There's no fractions, so we don't need to use the quotient rule. But there are like terms there, so we need to add and subtract to like terms. So let's first look at the set of like terms that have the highest exponents. If you look closely, I see 80x squared and negative 45x squared. Now, if you combine those two, we're going to get negative 35x squared. Remember, when you put these into the calculator, you're not putting x squared into the calculator. You're putting 80 minus 45. We're only going to put the coefficients. So then we have 3x and negative 130x, which is going to give us negative 127x. And then lastly, we have negative 50 and negative 12. That's going to give us negative 62. And this is our simplified version of the expression. It's more simple to look at. It's smaller than this big old thing right here. Now it's your turn to try a problem. We have 3 times 5y plus x times negative 2 plus 10x minus 4 times 8x minus 2y. Take a moment to pause the video and write down this expression, simplified. All right, let's take a look at how to simplify this expression so that we can see if you got it right. So first things first, let's write down the order of operations. We have P for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. First, we're going to look at all the parentheses. If we look at the inside, we have some multiplication going on, not in the second set of parentheses, but in the first one. So we're going to go ahead and simplify that first. According to the product rule, we multiply x times negative 2 and get negative 2x. We didn't change the 5y, so we're going to keep that there. And then we didn't change the 3, so that's still there as well. Then we have 10x, because we didn't change that either. Negative 4 times 8x minus 2y. Now that we've simplified the inside of parentheses as much as we can, we're going to simplify the outside. So we have 3 times 5y, which gives us 15y. 3 times negative 2x, which gives us negative 6x. We did not change 10x. We have negative 4 times 8x, which is going to give us negative 32x. And negative 4 times negative 2y, which gives us positive 8y. So we're done with parentheses. There's no power rule. There's nowhere where we need to use the power rule. We use the product rule. There's no fractions, so we don't need the quotient rule, but we need to add and subtract like terms. So let's go ahead and pick those out. So I see a bunch of x's and y's, so first I'm going to start with the x's. These are all the terms that have x's, so we have negative 6x plus 10x, which gives us negative 4x. And then if we subtract 32x from that, that gives us negative 36x. Then we have the terms with y. So we have positive 15y and positive 8y, so we're going to add them. And we're going to get 23y. So now that we have our solutions, we're going to put them together. And altogether, you should have gotten negative 36x plus 23y. If you wrote it the other order, 23y minus 36x, that's still correct, but we typically write it in alphabetical order. If you got this right, good job. If you like this explanation on simplifying expressions, Make sure to hit the like button below and don't forget to subscribe. Thank you everyone for watching. I'll see you in the next one.